Hello there, and welcome to the May edition of the Manitowoc Ice Monthly Spotlight. My name is Jason MacDonald, Technical Service Trainer here at Manitowoc Ice. Today we're going to talk about the Indigo and the Indigo NXT control board LED and what they mean to us. So we'll talk about both machines. Mostly we're going to highlight Indigo and then tell you or Indigo NXT, and then we're going to tell you the differences of what its predecessor, the Indigo, did. So we'll go over to the split screen and we'll start sharing our presentation. As we do every month, we will have a seminar quiz at the end of this. You need to provide things like your name, your email address. We like to know company names so we know who's watching and taking our quizzes. But then answer the questions and at the end, click submit. Otherwise, you won't get a grade and we won't know you did it. We won't have a way to reach out to you. Once you do that, we'll reach out with a PDF version of this presentation, a certificate of completion, as well as enter you for our monthly drawing of our swag bag that we do with each webcast and seminar. Webcast was the predecessor, but now we're doing our monthly spotlight, so we'll do it for the spotlight. All right, we're going to talk about the Indigo NXT control board lights. We're going to start with the inputs and the sensor lights at the top right-hand side of the board. So the micro display, clean, and harvest lights. They're going to be up at the top right-hand side of the board. That's assuming that this is a machine that is not an ice beverage unit. 22-inch, 30-inch, 48-inch machines, whether they're air-cooled, water-cooled, traditional or remote, or a quiet cuber that is not an ice beverage unit, the board will stand up and down. On the ice beverage units, they sit sideways or horizontal, so we're going to go from the perspective of vertical. But they're going to be up here, 34-1, -2, -3, and -4. The display, the micro light, the clean, and the harvest light. If you're in a clean mode, because you utilize the user interface display, press clean and follow the prompts, that clean LED will light up. It'll also light up if you're utilizing an automatic cleaning system plugged into the board. We'll talk about that on another day in another presentation. It'll let you know that the machine's in its cleaning mode. And during a harvest cycle, that harvest LED will also light up. But what we're going to highlight here are the display and micro lights. Up at the top there, you see some green flashing, which can be a little hard to see on a green board. But what we're looking for there, ideally, is that they're flashing. It does not matter if micro is flashing on, if display is flashing off, if they're flashing on and off together, as long as they're flashing. If they're flashing, that lets me know that the display is communicating with the board and the microprocessor is functioning properly. They need to be flashing, not lit solid, not off, flashing. Again, the interval does not matter as long as they're flashing. So next, we're going to talk about our input devices. Remember, an input device is anything that plugs into the board to give it a signal. Those lights are going to be green. Those LEDs, they're going to be green for input devices. And they're going to be up here at the left, 34-5, -6, -7, 8, 9, and 10. And you'll see there on the right-hand side, it's letting you know on the legend. So when you open up a technician's handbook, if you looked at this board, if we tried to put all the words in there, it'd become a very busy document. So what we did was we utilized numbers, and then on the subsequent page, it'll tell you what those numbers correspond to. So we're going to start with the first input device, the water level probe. Remember that this is a 3-prong probe. You've got 2 long sticks and a short stick. The 2 long ones are going to be your low and your common probe, and then the short one's going to be the high. So as that water starts to rise, it's going to touch the 2 longer sticks first, and that LED that you see lit up now will light up, letting you know that the low probe is satisfied. It's there to measure conductivity for diagnosis and for our water settings. Water miser on the old Indigo, or the use less water with reverse osmosis, as you'll see on the Indigo NXT. It's the same on Indigo as it is on Indigo NXT, or the ice clarity feature. So as we fill up with water and we touch those 2 longer sticks, that LED will light up. If you were looking at your user interface display, it shows service, data, real-time data, and inputs, because again, this is an input device. You'd see that water level low went from not sensing to sensing. But should you not have functionality on the display, you could troubleshoot the water probe utilizing these lights on the board. As you continue to fill up, then that short stick is going to end up touching that short probe. At that point, I would expect the light to the left of the low probe light to light up, letting you know that the high probe is now satisfied. Now, ideally, as you're filling, I would expect, everyone in tech support would expect, that both lights would be lit. First the low probe light, then the high probe light would light up next. But this is a good graphic all the same, not just because it's more visually appealing to see 1 light over 2, but what you could see at that point is, hey, the high probe satisfies, but the low probe doesn't. That's going to let you know there's something going on with that water probe, or maybe the connection on the board going on there. You can troubleshoot your water system diagnostics in accordance with your tech handbook to see what's going on, tell the board what you want to know by doing some jumpers, and get the lights to light up. If they do, you know it's going to be the probe. You could ohm out that probe as well, but ideally, with a proper functioning ice machine, proper functioning water probe, filling with water, I would expect that the low probe would satisfy first, then the high probe would satisfy next. But if you did see this, you could see water faults in your future. All right, the ice thickness probe LED. This one is one that we get a lot of questions about. So on previous versions of Manitowoc ice machines, so the S model, the Q, the J, and the B model, they all used a water sensing ice thickness control probe. So we were not sensing ice, we were sensing the water going over that ice. So anytime water would come in contact with that ice probe on those machines, it would flash. And as ice formed, and you had constant contact with that ice probe, that light would light up solid. That's not what we're doing here. The Indigo and the Indigo NXT use a acoustic probe, so it's listening to that ice. It can hear the sound the ice is making as it forms. So that light does not serve the same function on an Indigo or an Indigo NXT that it's served on the S model and before. So do not use this light for troubleshooting. That light can be lit when this probe is calibrating, when it's sensing. I've seen it lit in harvest. We do not utilize this light to troubleshoot the same way that we did on the S model, Q model, J and B, and any other machine that use either a single wire or dual wire water sensing ice thickness control probe. So do not use this light for troubleshooting. What you want to use is what we're going to show here in a second. You want to, assuming that you have a functioning display, you want to go menu, service, data, real-time data, and then inputs, because again, the ice probe plugs into the board. It is an input device. So at that point, you want to look at the 100 hertz and 120 hertz FFT ratings. As the ice starts to form, those numbers will climb. If you were doing a tap test, as we've taught in our field schools, factory schools, and on our online trainings that you've seen before, you would start with no ice on the plate. You should see those numbers lower, and as you scratch on the bump of that ice probe, they need to climb. If they climb, the probe can hear, and the board can recognize what the probe is telling it. Do not utilize that light to troubleshoot the ice thickness control probe on an Indigo or an Indigo NXT. All right, the display bypass. So on Indigo NXT, we have a way, should the display that I have behind me not be functioning, whether it's my icons on the touchscreen don't work or the buttons up top are not responding. What you would do at that point is you would unplug the user interface display, and you would end up seeing this light once you utilize the button we're going to show you here shortly. 34-8 would be lit up. So what you do is you push and hold this black button here, and you will hear a click, and you'll see relays light up, which we're going to talk about here shortly. And that will let you know that you're in the display bypass, and you'd see that light there on the right on the control board light up, letting you know that you've bypassed this display. You'd get 7 days of operation before the machine would shut itself back down. This gives you time to go get a part and replace the malfunctioning display and get another one in there. You can do this more than one time. 7 days go by, you haven't gotten a display yet for whatever reason, you could go push this again and get 7 more days of operation. All right, but curtain lights or magnetic bin switch indicating lights, they're going to be these two, 34-9 and 34-10. Keep in mind, we offer multiple versions, configurations of the Indigo NXT and Indigo ice machine. We have single evaporator, single circuit ice machine, so one plate, one TXV, one harvest valve. We have single plate dual circuit machines, so one evaporator, 2 TXVs, 2 harvest valves, independent circuits, or dual evaporator ice machines, multiple plates, therefore multiple circuits, needing to sense multiple curtains or dampers. So on a single evaporator ice machine, so regardless of the number of circuits on that machine, just one plate, we're going to utilize the R bin light to call out that the curtain is closed. You'll see that light there. If the curtain, as it is behind me, is currently closed, that light would be lit. If that curtain came open, that light would turn off. Now, if you're suspecting an issue with that curtain switch, the magnetic bin switch, you're going to want to ohm that switch out. I've seen this light flash before when the curtain didn't move. So when in doubt, ohm it out. You should see about an ohm or less when that curtain is closed and open line when open. We're looking for some consistency there. You don't want to be dancing all around. 1.0 or less when closed and open line when open. When in doubt, ohm that curtain switch out. Now, the dual evaporator machines, so the IF 1400, 1800, 2100, as well as the IT 1830, they utilize two evaporators. So we have to use two dampers. Dual evaporator machines use ice dampers. Same theory. It's a magnet inside of a flapper instead of a curtain, communicating with a magnetic bin switch, a reed switch in there. Now, this one gets a little confusing because we call out our bin, but think of it from your perspective. The light on the left will correspond to the left-hand damper, and the light on the right will correspond to the right-hand damper. So ignore the label. Look at where the lights are. Left-hand side, left damper, you flap it, light goes off and back on. Same would be true with the right. All right, so output devices. Notice previously on those input devices, all those lights were green. On output devices, these lights are going to be red. So the compressor relay, keep in mind on machines where the compressor is inside, we are actually sending voltage to the contactor coil. And that red LED next to it, that's a predetermined response. When it is time to energize that relay, that LED lights up. That does not guarantee that we are sending power from that relay to that contactor. So what you'd want to do at that point is look at your wiring diagram and find the wires you would be checking across. You could do this at the board or at the component. If you check across the contactor coil and you don't have power, well, you could also check at the board at wire number 58, and 56 is going to be common to all of your outputs. It's the L2 line coming into the board. So 56, 1 meter lead against it, 58, 1 meter lead up against it. On a 115 volt machine, you should see 115, 208, 230, same should be true, should see 208, 230. Now, if you're seeing 0, or you're seeing 14, which is what we usually like to refer to as ghost voltage, well, now you know the relay doesn't work on the board. Go ahead, pull that board out, verify there's nothing on the back of it. If there is, get that off of there, do this test again. Nope, still no voltage. All right, you've got a defective relay. Go get yourself a new control board from your Manitowoc Ice parts distributor in your area, program in the model and serial number, and you'll be back off to the races. We energize this during refrigeration startup, freeze, and harvest. All right, our water pump. It's the second relay from the top, all 22-inch, 30-inch, 48-inch air-cooled, water-cooled, traditional remote, and again, the non-ice beverage quiet cube ice machines. So what we're looking for at that point is we're looking to see with the ice beverage, this board's going to be turned horizontal. You just got to get your perspective, look at your diagram, and you'll be able to see where everything is. And also on the sides of the relays, it is labeled which one is which. But again, we're in freeze now. That's when the water pump is supposed to run. Well, what we're looking for at this point is water to be over this evaporator. Well, I've got water in the trough. How do I know that? Well, I saw my input lights. I saw with a working display. So I saw my water probe lights in the board are lit. I see that water is sensing. I even put my finger in that trough. I've got water and I'm in freeze. How? Because I've got a working display and real-time data told me I'm in freeze. Well, no water over the plate. If you go across wire 57, that gray wire, and 56, that white wire, and you've got 115 volts on a 115 volt ice machine, or 208, 230 on that style ice machine, and no water's moving, well, you've got a problem with your pump. If you have no voltage, you have a problem with that relay. At that point, you'll know which component to diagnose. Voltage to it and output device isn't operating, it's the output device. Light lit next to the relay and no voltage coming out, well, it's going to be the relay. Relays are not replaceable. Again, this will be energized during water purge, freeze, and the first 45 seconds of harvest. We do a harvest purge. All right, the water inlet valve. This is supposed to come on during pre-chill and then again during freeze to bust up any slush. But assume that you're not getting water. You verified that you do not have a water probe that's sensing, both by utilizing the input lights for the low and high water probe, or you have a working display and water low and water high both say they're not sensing. You could check across wire number 20, that blue wire, and wire 56, that white wire, and check for voltage. If you have line voltage and no water coming to that ice machine, well, you've got a working board. You have a probe that's not telling the board it already has water, so you need to go verify, do you have water coming to this ice machine? Hey, you turned off the water valve, supplying the machine, you took the line off, turned the valve back on and filled the bucket. Okay, you've got water. Now you know the water inlet valve is either plugged up and needs to be cleaned or needs to be replaced. And if you don't have power and you do not have a water probe that's telling you you already have water, either by utilizing the input menu in real-time data or by looking at the lights for the low and high water probe, not sensing on the screen, no lights lit on the board, no power from the relay, well, now you know that the relay on the board is what's your issue. You'd replace the board. But if you've got power and no water, well, the board's doing its job. It's calling, and it's just not giving you any. All right. We talked a little bit about single circuit, single plate, and dual circuit, dual plate machines. The left-hand harvest valve relay is utilized on every machine that has one evaporator, regardless of how many circuits it has. So we energize that relay during our equalization period for a softer startup, and in harvest it will energize on a dual circuit. So think a big 48-inch wide ice machine, left circuit, right circuit, two harvest valves right together. That left-hand harvest valve relay is energizing both of those valves. It will also energize an HPR solenoid valve on a traditional remote that utilizes the HPR system. And if you've got power to one, you should have power to both. You could check for power coming from wire 61, it's a red wire, and wire 56. So you're in harvest, you're not getting any heat, and you're not sure if that valve has energy. One lead to 61, one lead to 56. You've got line voltage, depending on what the line voltage is for that ice machine. You know that you have power, you know you're chasing a valve. No power, you know you're chasing a board. Again, during equalization, refrigeration startup, and harvest, these are going to be on. All right, but the water dump valve, it's the fifth relay from the bottom. It's going to correspond with wire 60, that black wire, and wire 56, that white wire. So what you're looking for there is power across those two. Keep in mind, the pump is on during water purge and during freeze and during the first 45 seconds of harvest, as we refer to it as the harvest purge. It's the fifth relay from the bottom. Again, the thing that I'm wanting to stress today in our spotlight is if the LED is lit, you have to verify power, either at the components or at the board. You can go across the two wires, find your common 56 and find L1, go into that component and check. Dump valve says it's on because you've got the relay, you've got no power, relay's not sending out. Dump valve is not letting water through, you do have power, you've got a clogged up drain line or a restricted dump valve or a defective dump valve. All right, and then the right-hand harvest valve. The last relay on the bottom, this is only utilized on dual evaporator machines, not dual circuit, single plate, two evaporators side by side. So again, that IF 14, 18, and 2100, this will come on every time that the left-hand harvest valve comes on machines with multiple evaporators. And you can check across 62, which is a red and white striped wire, and 56, the white wire. All right, so we highlighted what's going on the Indigo NXT control board. What about that Indigo control board? What's different there? So we're going to talk about the similarities first, just so that way you know, hey, you're not really troubleshooting a lot of the differences overall. So the inputs, one slight difference with the inputs. For the water probe, there's only one light, and it's corresponding to the high probe. So if that WLP light up at the top there is the second one from the left on the left-hand side, if you've got a trough full of water and the high probe is satisfied, that light will come on. Indigo NXT does have two, one for the low probe, one for the high probe. And we still have the R and L bin lights, but the outputs are all the same. Same bits, top to bottom, what they're supposed to energize and how you would check them. Same thing with the wiring, same numbers, believe same colors. They should be the same colors, but I always go by the wire number, just in case you can't see color, or just in case they were out of blue that day. And up at the top, that's going to be the same for the first four lights. Micro display, they're supposed to be flashing on and off together, one on, one off. Does not matter. What we care about is that they're flashing. You still have a clean and a harvest light. So all of those lights function the same with that one little difference on the water probe. Now, keep in mind, again, water probe light only for the high probe, but the inputs, outputs, display, micro, clean, and harvest are all the same. But where we get some differences on this board, the Indigo board, not the Indigo NXT. Indigo was the first machine, LCD display with a touch pad with push buttons. We had a SL1 for safety limit 1 and an SL2 light. Say that the machine is off and the touchpad is inoperable. You could open up the control box and see why is that machine off. if one of these two lights was lit, you could find out that, hey, this machine shut off on safety limit 1, as we show on the screen right now. That's long freeze. Or you could see there's that. Again, this is not present on the Indigo NXT. Or the safety limit 2 long harvest light. We have two safeties that shut the machine down. We're taking too long to make ice a certain number of times in a row. Refer to your technician's handbooks to verify how many cycles for which version of software, or too long to harvest that ice. We made ice and we went into the harvest sequence and we did not drop during the maximum amount of time allowed based on the version of software. Those lights are there. And again, that light is not present on the Indigo NXT board. All right, but also there's a difference here at the bottom left that you'll see that CVD relay. The Indigo series ice machine had a 5-strand 18-gauge wire that allowed the outside unit, the condensing unit, to communicate with the inside unit, as we refer to the ice machine head. It allowed us to see what the low pressure and high pressure switches were doing outside, and it would allow us to communicate, get the machine to shut down, ensure that the full bin delay and everything else was going on. This is not present on Indigo NXT. There is not communication between the two units, and that light would be there. For those of you who have come through trainings and through the factory school, we highlight what this light is doing. You want to use this light in coordination with a working display, so that way you can see, hey, I'm in freeze and this light isn't lit. Well, that lets me know something in the low pressure circuit told the board that the low pressure switch opened. If the high pressure circuit had opened outside on a Indigo, the home screen would say HPCO active delay and give you a 60-minute countdown. The light, the relay, and the communication wire are only present on Indigo. They are not present on Indigo NXT. So that's how the LEDs on our control boards for the Indigo and Indigo NXT work. I'd like to highlight some upcoming spotlights. We've gotten a lot of questions about lights before, so next month in June, we're going to talk about the Neo and Cool Air LEDs, because what you'll notice is the Neo undercounter and the modular Cool Air, so the ones that sit on bins like this Indigo NXT behind me, they share a board. So we're going to show you what those lights do, how they react to the ice machine in question. In July, we're going to talk about quiet cube refrigeration systems, and then in August, we're going to talk about installing an iOX on a Indigo NXT ice machine. And you'll notice we only have the next 3 months listed, so if you've got ideas for future spotlights, feel free to snap this QR code. I believe we will have the link in the comments on the YouTube video, and tell us what you'd like to see. Hey, you know what? I want a longer topic about X or about Y. We've got Tanner in the background. He's helping with all of the recording here today. So Tanner and I only have so many ideas. The rest of tech support only has so many ideas. Take advantage of this. And our spotlight quiz, again, we're going to be able to utilize. And you have to click submit like we told you in the beginning. Give us your name, your email, all that information, so that way we can actually contact you after this has been done. And that will put you in the drawing for our monthly swag bag. Again, we will draw one winner for every 25 quiz submissions. So should we get 50 between now and when we post the June spotlight, we'll draw 2 and so on. That's the key with the hit and submit there that we need, because if you would have won and we don't have a way to contact you, how are we going to get an address and tell you that you won? And now that spotlight quiz. I'd like to thank you all for watching. We love doing the longer topics. Also check out our Ice Tech Fact series. Those are short and to the point, less interactive, but just, hey, here's a problem and how we fix it. So we'll leave this up on the screen so you can snap it. Good luck on your quiz. Thank you for watching today. Again, my name is Jason MacDonald, Technical Service Trainer at Manitowoc Ice. Thank you.